Hi guys, can we please take out our packet and can we look at page 2? And then pause the video, and I want you to do numbers 1 through 5 and then come back and check your answers. And then the homework is going to be to finish page 2 for numbers 6 through 10. Okay, so again, I'm hoping that you pause the video and you try this on your own first before you're watching this portion. So I figured I'll leave the easy one for you to do at home because the hard one was the one that we did in class. So our basic cubic polynomial is x cubed, and we're going to go find its parent graph so then you can use transformations to graph the rest of them. Showing 5 points, so you can make an x and y table, and 0 cubed, 1 cubed, 2 cubed. I'm not going to do 3 cubed because it's quite large, but I will do negative 1 cubed, and it's 1. Negative 2 cubed, and that is positive 8. So 0, 0, 1, 1, negative 1, negative 1. And then I'm going to plot 2, comma, 8. And then I'm going to plot negative 2, comma, negative 8. So I'm just going to use a pencil to sketch this. And this is what it would look like. Not linear, even though I'm trying my best, like that came out to be too linear. So not very linear, as curved as possible. And this is what it looks like. So the domain of this graph is because I can plug in anything I want for x. I can take any number and cube it. So the domain is from negative infinity to positive infinity. And the range of this graph is I can get oh, sorry, that's not right. That's negative 2, negative 8. And then when I plugged in negative 1, it was negative 1, which is this point right here. The range is I can get 0, I can get positive numbers, I can get negative numbers. So the range is also from negative infinity to positive infinity. All right, let's talk about where this is concave up. So let me go sketch it. And it's okay if you have trouble with 3 and 4 on your own. This is why you're watching the video. So when we graph x squared, we know this is concave up everywhere, so this is y equals x squared. When we graph y equals negative x squared, we know it's concave down everywhere, and this is concave up everywhere. And the only way right now I can explain the difference between concave up and concave down, notice how this one opens up and this one like opens down. So for example, some random curve. Here's a curve that's concave up. Turns out it's decreasing and it's concave up. Here's a curve that is increasing and still concave up. So concave up turns out it's decreasing. The two are not related. And concave up and turns out it's increasing. Concave down, here's something that's concave down. Turns out it's increasing and it's concave down because these were concave up. I can draw something that's concave down and decreasing. So here's something that's concave down and decreasing. Concave down, notice that's opening downwards, and this is opening, if I used my hand, it's opening upwards. This is opening downwards. X cubed, I'm going to draw x cubed really exaggerated. This is what x cubed looks like. X cubed is not concave up everywhere or concave down everywhere. It changes, and the word is concavity, where it changes concavity. So I'm hoping you're convinced that here it's concave up. And then once it hits 0, here I'm hoping you're convinced that it's concave down. So this graph I think does a better job convincing you. I'm hoping that this is concave up and this is concave down. So let me go back to this. So the part where I actually like this graph better than that graph. The part where it sort of flattens out, like as cheesy as it sounds, it gets a little tired, it's going, it flattens out, it gets a little tired, and it continues. The part where it flattens out, that part is for the parent graph, it's at 0, 0. So when you're describing an interval where f is concave up, let's use the x values to describe this portion, x values to describe this portion of the graph. So pause the video if you were stuck the first time, do 3 and 4. And if you weren't stuck the first time, then here's the answer. It's concave up from negative infinity to 0. We're not going to include 0 because I have no idea what it's doing at 0. Exactly 0 is where it changes concavity, and I don't know what it's doing at 0, so we're not going to include 0. and it's concave. Did I make a mistake here? Nope, concave up, and then becomes concave. I did make a mistake, so sorry. Concave down, concave up. Sorry about that. Concave down, and then concave up. So concave down, this is wrong. No, yeah, this is wrong. Concave down is from negative infinity to 0. This part's concave down, then it becomes concave up from 0 to infinity. And again, as the graphs get complicated, they're not always going to be concave up. They're not always going to be concave down. They're going to be a little bit of both. And lucky for us, this is actually easy to tell that at x equals 0 is where it changes from concave down to concave up. Okay, does the graph show any symmetry? So the answer is yes, but I'm going to discuss what that symmetry is in class. You should write down so you're prepared to participate in the discussion tomorrow. It has some sort of symmetry, meaning I can do one transformation or a couple of transformations to get this graph mapped onto itself. Like, for example, y equals x squared. If I take y equals x squared and reflect it over the y-axis, it goes onto itself. This parabola will get reflected onto itself if I reflect over the y-axis. This is why it's symmetric over the y-axis. What is this symmetric over? Which transformation will I do so that this graph given maps onto itself? So please come prepared to class with what the answer is, what this symmetry is. Okay, that's it. So please now do 6, 7, 8, 9, and 10 on this page.